Let's move on with primary trigonometric ratios for any angle. Here is question number 5. For cosine theta equals to 3 over 5, where theta is greater than equal to 0 and less than equal to 360 degrees, draw a sketch of theta and determine tan theta. I'm Anil Kumar, and this one is actually a thinking and communication question for you. We are given a value of cosine theta as 3 over 5 and also that theta could be between 0 to 360 degrees. What does that mean? It really means that if I consider my coordinate plane, then theta is angle between 0 to 360, so it could be anywhere in this plane. When I say cos theta is 3 over 5, note it is positive. So when is cosine positive? Cosine is positive in quadrant 1 and 4. If you remember the cast rule, let me write down CAST. So cosine is positive in quadrant 1 as well as in quadrant 4. Now knowing this should help you solve the given question. It says cosine theta is 3 over 5. Now what is cosine theta? Cosine theta is, when we say cos theta equals to 3 over 5, it basically means adjacent side over hypotenuse, right? I'm writing them in short form, in a right triangle. Now in this particular case, adjacent side is positive when x value is positive, right? So it's kind of 3, so it is 3 on this side. Let's say this is 1, 2 and 3. 5 actually is the hypotenuse, right? So it is over here. Let us say this length is 5. So that point represents the point P for which the angle is theta, right? So this is one of our angles, theta, right? So what we have here is 3 units along the x-axis and 5 units along the radius or hypotenuse. That makes it cos theta value of 3 over 5. But remember one thing. If you consider a triangle which is a kind of reflected image right there, P dash, here also the value of cosine theta is 3 over 5. So that ways we get two cases. One, when the angle theta is in quadrant 1, and the other case is when angle theta is in quadrant 4, right? So we have two different cases here. So we have case 1 when theta is in quadrant 1, and in case 2 theta is in quadrant 2. So these are the two different cases. Now for both these cases we should find the value of tan theta. This is what is kind of important to understand. Now to find tan theta we need to find what height is, right? That is to say, we know at present x value, but we don't know y value. We need to find the y value, right? So this y value could be found from the given hypotenuse and adjacent side. So we have y as equal to, from here we'll write y as equal to square root of 5 square minus 3 square square root. That is square root of 25 minus 9 square root. Now 25 minus 9 is 16, and that gives you a value of 4. So the height is 4. So both these triangles are congruent. That should also be 4. But here the coordinate point should be what? Well, this is case 2 where coordinate is 4. So what we are looking into is a point P whose coordinates are 3 and 4 when it is in quadrant 1. What are the coordinate points when it is in quadrant 4? It is indeed 3 and minus 4. That makes the difference. So in one case where theta is an acute angle, in that case tan theta is equal to y over x, right? which is 4 over 3. But in this case, tan theta, where theta is an obtuse angle, theta is this angle. Do you see that? The whole thing like this. Here, the value of tan theta is minus 4 over 3. It's a negative of 4 over 3. So we get two different answers. That is because when we are considering theta between 0 and 360, there are two different positions. One, when the point could be in quadrant 1, in that case tan theta is 4 over 3 positive. Second is when the point could be in quadrant 4. In that case tan theta will be minus 4 over 3. So we have to give both the answers, and that is kind of important to understand. I hope you appreciate it. Thank you and all the best.